Hey, this is Don from Padlock Technologies again, here with another video, another question that was asked to me about HA when it comes to routing. And actually, should I let the firewall do the failover, or should I move the failover up a level and let the routers do it? That's a very simple question. It really depends, right? It's really a money thing. Do you have the equipment to utilize a better HA strategy? So what do I mean by that? So most people, they get two firewalls and they will configure them in HA. So this is firewall 1, this is firewall 2, all right, was it 1 and 2? And we'll have, depending on if you want to have a stateful link and a failover link, or this can be a port channel or some source or something like that. And then you do downstream to a switch, right? And then from the upstream level, you can have a kind of dirty switch there. And then that goes off to a router to the internet. And then you have cable there, cable there. Now, the problem with this is when you run into a separate ISP and you're running something like BGP. BGP here. Now, when you're doing this, I have seen in a couple implementations where when a failover happens from primary over to secondary, the BGP adjacency goes down, or some weird routing happens where, especially if these are two different service providers that are hooking in, say this is Comcast and the other one is like Verizon, they get weird when it comes to advertising routes, and then the routing can get, asymmetrical routing, and you have some weird things going on. And what ends up happening is, what I've seen is, if you're getting quad zeros, the quad zeros end up not showing up in the secondary firewall that's now the primary, and then all traffic is pretty much black hole there. So you have to watch out for that. And since I've seen that in a couple use cases, I don't really tell people to do this method if we're going to do BGP directly with the service provider. Now, if you're going to do something like this design, which is you have router 1, and then you have router 2, all right? Now, you can have switch in the middle, all right? You're running some type of first hop redundancy protocol like, that's a P there, like HSRP, VRRP, that's what you typically run. You're not gonna run, the other one is GLBP, but most people do not run that because I think that's deprecated now, but most people don't run GLBP, at least from a routing perspective. And then you have SP1, service provider 1, service provider 2, each doing the individual peering. So you'd have BGP here. Now this can be whatever service provider you want. And then you have BGP here. Now you have to be careful because now Cisco kind of teaches you, if you want to manipulate routes, you can use MED or ASPath. In the real world, you're not going to be able to do MED or ASPath. Why? Because ASPath can mess up routing past the service provider that you're peering with. So they kind of don't even allow it. In fact, if you do send them an ASPath prepend, they will strip out the ASPath prepend. So it's almost like it doesn't exist and doesn't even work. So what they normally will do is, if you wanted to, let's get back to the design here though. If you wanted to, let's say the firewall 1, and then you got firewall 2, running HA or whatever, down to the core level, to the switch, the switch core switch. So now, the only thing you really need to worry about is setting up a quad 0 route. So a default route going to the VIP between these two. So the VIP, right? And then they handle all the routing out to the ISP. It's a lot simpler to just have the static route, right? Because that static route, and when a failover happens, when it turns over to this box, that quad 0 will always be there because it was on the primary, and it still points to the VIP of the routers. Now, this is not as super advanced design, but it's a better design than having your ISPs plugged directly into the firewall, and then you're trying to do some manipulation there. Plus, if you own the prefixes, it's like, again, if you own the prefixes, it's easier to advertise it from the routers and stuff like that. If you want to do route manipulation, it's way easier to do route manipulation on routers and firewalls. I come from the old school of a router is a router, a firewall is a firewall, and a switch is a switch, right? A firewall is good at security, right? It's great at security, kind of sucks at routing, right? Sucks at routing. A router is great at routing, sucks at security. All right, sucks at security. When you try to marry the two in one, it's not going to be good in either area, and it could cause some design issues later on down the road when the limitations of an all-in-one box start to come into play, right? So I would do this type of design, and then if I wanted to have two different ISPs, you can do two different ISPs, and from the ISP standpoint, they will say, send me this community value, and then when I see the community value, what I'm going to do is manipulate the local preference so that if the local preference is lower, going toward this would be the CE, technically router 2 would be the CE. If it's lower and it's higher somewhere else, I can manipulate the traffic going somewhere else, right? Because by default, the local preference going towards the CE is always going to be higher than anywhere else, from a peer or from a tier 1 or a tier 2 peering or a tier 1 provider, something like that. So those local preferences are going to be lower than something coming directly from the router that owns the routes. So hopefully that answers the question about whether you should do, have an all-in-one box and have the routing being manipulated there versus this is kind of, they call it big boy setup, but this is not really. But this is a better design to have stability in terms of internet and default routing, and then controlling your routes via the routers that you own upstream. And the key is you have to own the routers to be able to do this. If you don't own the routers to do this, this is pretty pointless. And if you're not doing like BGP pairings and stuff like that, that's pretty pointless as well, right? If you're not doing BGP and you're kind of just doing a static route, you don't need all of this. This is pretty much stupid in my opinion, unless you have two different ISPs, two different geographical locations. They're not running in the same line. So if someone digs up a line, it doesn't dig up both of your ISPs. If you're doing that, then you can kind of get away with this as well. Hopefully that was informative. This is Don from Padlock Technologies. Thank you and have a nice day.